Bright Tuty. Every student matters.
Hello students, let's continue the chapter Exponents and Power. As I told you, we are now going to do the standard forms, right? The usual form and standard form of exponent. So where is it actually used in real life? So you see there are many examples when we have to express very small numbers or very large number. Standard form is really helpful. So when we have to say the distance from the earth to sun is just to see this number, this is a very large number, right? And it is difficult to read it out. So to make the reading or speaking of the numbers very easy, we use standard forms. Similarly, speed of light, right, 20 mm, 0.000007, like, so these are very small numbers, right? And these are very large numbers. So to express them, we will use standard form. How is it helpful in that? You will learn further. So just look here. For example, suppose this is there, right? And we have expressed it as 1.5 into 10 to the power 11. So just see, putting a decimal after it doesn't make any difference. So this decimal, how many places we have shifted? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. After 5 we will be putting it. So 1.5 into 10 to the power 11. That means when you move to the left side, right, into that many places you have to write. Like how many places? 11 places we are moving. So that number of places will become the power of 10. Right? Why does that happen? Just to see. We actually are writing 1.5 into 10 to the power 11. How do we get that? How did we write it directly? So just to see. We have 1, 5 and how many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 to the power 10. Okay. Now I will divide it with 10 to the power 10. Right. If I do that, I have to multiply also with 10 to the power 10. So one of them will get cancelled up, right? Also what I can do is I have to put a decimal, right? So what I need to do, instead of 10 to the power 10, what I have to do, I have to write 10 to the power 11, right? So that can be broken into 15 into 10 to the power 10 upon 10 into 10 to the power 10, that is 10 to the power 11. If I do that in denominator, I have to write 10 to the power 11 in the numerator also. So this would get cancelled. This will form 1.5 into 10 to the power 11. Right. So actually what is the standard form? That this will be the whole part. Okay, has to be 1, 2, 3. It has to be any number, right? A natural number. And then we can have any number here after this. So what can we learn from this is that when we have to express the standard form, the whole part will have one digit. Okay, it will have one digit, and from 1 to 9, and the decimal part can be any number including 0 as well. So always we are going to try that we have one digit and then we have the one decimal, and then we can have any number of digits into 10 to the power something. That something is decided by this decimal point. As in this case there was no decimal and it's a very large number, so to read it out is difficult. So we know that at the end we can put the decimal. I shifted the decimal to 11 places and I got 1.5 into 10 to the power 11. So one thing that we need to learn is, right, the concept is clear here, but the thing to learn here is if we are moving towards right or left. So in this question we are moving towards left by 11 places. So we write the decimal at that place. So after 11th place, that was 5, here we have put a decimal, so we got 1.5 into 10 to the power 11 we are writing. Clear? So now we are going to do the second part that will make the concept more clear. So what we are given in the second part, just to see, we are given that we have to try to express 0.000, how many zeros? 1, 2, 3, 4, 5. 007. This we have to express in standard form. Now we know that this is the decimal here. Okay, we cannot express in standard form because this is not the standard form, because here is 0. 0 cannot be at the place. So we can't have point here, right? Because we need to have one natural number in the starting. That means the before decimal place. So this would be shifted here. after 7. So how many places? 1, 2, 3, 4, 5, 6. So we will write it as 7 into or 7.0 into 10 to the power minus 6, because in this case we are moving towards right. Why did I write minus 6? Just look here. 7 upon how many decimal places? Just 1, 2, 3, 4, 5, 6. So 10 to the power 6 you will write. That will become 7 into 10 to the power minus 6 in the numerator. Right, that's why I wrote minus 6 here. So when you do that, 7 upon, you remove the decimal and you write it, because this is not the standard form. In standard form, the whole part should be a natural number. It should not be 0. Okay, so 7 is a natural number in this, and we wrote 7.0. So we have shifted the decimal towards right. So what's the rule to remember? Every time you will not multiply and divide with something, right? So what you need to remember is, whenever you move to the left side, okay, so when you move to the left side, what you need to do? 10 to the power that many number of places. Like in this case it is 11, in this case it is 6 places towards right. Okay, so we will write 10 to the power that number with a positive sign, 10 to the power 11. But when you move towards right, you have to write the power as a negative number. Okay, so next question here, let us try some of the questions so that the rule is also learnt here itself. So in the first part we have 0.12345 6 zeros, 1 2 3 4 5 6 5 6 4. So is this standard form? This is not a standard form, because whole part is 0. The whole part should be a natural number, so we have to shift this to here with 5. Okay, so just see how many zeros do we have if we remove the decimal. 1 2 3 4 5 6 7 8 9. So you can just write 5 6 4 upon 10 to the power 9. Clear? So we get 564 into 10 to the power minus 9. But is it the standard form? No, we need to put a decimal after 5 or before 6. So we will divide it with 100. So multiply also it with 100. That's what we are going to do. So when we divide it, it will form 5.64, and we can solve it further. Before this, what we can solve, so see what we get, 10 to the power minus 9 into 10 to the power 2. So we get 5.64 into 10 to the power minus 7. This is going to be our answer, right? So we want the simple solution, the methods that give us the solution quickly. So what I made you learn is, whenever you are going to move towards right side, you are going to write the number into 10 to the power minus the number of places. So here if we see, how many places are we moving the decimal? 1 2 3 4 5 6 7. After 5 we are writing, so decimal will be placed after the 7th place, that is 5, into how many places did we move? 7. And which side? Right side. So minus 7 will come. In right, remember minus, left, remember plus. Okay, now we are going to solve them according to the rule. Okay, next is second part. We have 0 point, how many zeros? Then we have 1 2 3 4 5. 1 2 3 4 5 2 1. This is what we have. So where the decimal will be in standard form? It will be after 2. So 1 place, 2 place, 3 place, 4 place, 5 place, 6 places. We will write 2.1 into 10 to the power 6. But what sign will be there? Negative. Which side are we moving? Right side. So the standard form is 2.1 into 10 to the power minus 6. Okay, third part. We have 2 1 6 and 1 2 3 4 5. 1 2 3 4 5. This is what we have. So we want the decimal, we can just write it like this. Okay, so we want the decimal after 2 now. So how many places are we going left side? 1 2 3 4 5 6 7. 2.16 into 10 to the power 7, and it will be positive because this side, this time we have moved towards left side. The fourth part is 1524, and we have 1 2 3 4 4 zeros. We can put a decimal after it, that doesn't make difference in the question. So just see, 1 2 3 4 5 6 7. Right, so 7 places we will be moving. 1.5 into 10 to the power towards left we are moving, so power will be positive. Okay, so this is how we are going to write the numbers in standard form. Now we can move next. Just see, we have to write all the facts. given in the standard form. The first one, distance from Earth to the Sun is this much. So in the first part, just to see, we have 1496. 1496. And how many zeros? 3 and 3, 6 and 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I can put a decimal here. The number to read out is difficult. Shift the decimal. How many places? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let us count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 places we are moving. Right? So 1.496 into 10 to the power. Which side did we move? Left side. So it will be positive power. So now we can say the distance from the Earth to the Sun is 1.496 into 10 to the power 11 meter. That is easy to read with. Okay, next is the speed of the light is this much. Okay, so 3 into 10 to the power, how much do we have? 1, 2, 3, 4, 5, 6, 7, 8. So 8 we have, 10 to the power 8. This can be simply represented, and this can also be written as 3.0. The next is 20 mm. Thickness of class 7th mathematics book is 20 mm. So how do we express it? How can we write it? So we can say 20 mm is 2 into 10 mm, right? And we also know that 10 mm is 1 centimeter. So it can just also be said that it is 2 centimeter, right? Or we can say that it is 2 into 10 to the power 1 mm. Okay. The next one is the average diameter of a red blood cell is 0.000007. So let us do this. 0.12345. 1, 2, 3, 4, 5 and 1, 7 we have. Just see 1, 2, 3, 4, 5 zeros and 1, 7. So we are going to put this decimal here. So how many places to the right we will shift? We will shift 1, 2, 3, 4, 5, 6. So we'll get 7.0 into 10 to the power. Which side are we moving? Right side. So recall what I told you. Positive or negative power? Negative power. 7 into 10 to the power minus 6. The last one, that is saying the thickness of human hair is 0.005 centimeter to 0.01 centimeter. So 0.005, 0.005. How can we write it? We can write it as, see, the decimal will be shifted this place. How many places? 1, 2, 3. So 5.0 into 10 to the power. 3 places we are shifting. So minus 3 because towards right we are shifting. So we can just say the thickness of human hair is in the range 5 into 10 to the power minus 3, 2. Just see, we have 0.01. Shift this decimal here. That means 2 places. So 1 into 10 to the power minus 2 centimeter. Like this we can write. Okay. Or also we can express that into meters. Right. Okay, now next part, just see some more examples we have to show you the use of standard forms. The distance of moon from the earth is given to us. What is the distance given? Just see. So now what we have? 384, 467, 3 times 0. 384, 467,000 meters approximately it is given to us. So see, it is difficult to read some numbers like this. So just to see, suppose after this there is a decimal place. Shift this decimal 1, 2, 3, 4, 5, 6, 7, 8. So 3.84467 into, because see, why I don't write zeros? Writing zeros after the decimal doesn't make any sense. So how many places did we move? 1, 2, 3, 4, 5, 6, 7, 8. So 10 to the power. Which side are we moving? Left side. So the power will be positive 8 meters approximately. So to say this is easy for us. The next part that we have is here. So the size of the plant cell is given, it is 0.00001275. So shift this decimal after 1. Right? After 1, if we shift that, what are we going to get? How many places will we shift? 1, 2, 3, 4, 5. So 1.275 into 10 to the power 5. But what sign with the power? Minus 5 or plus 5? Just see which direction are we moving? Right side. So negative sign. Okay. The next one is 695000. So 695 and 000 kilometers we have. So we can write, see the decimal we can consider after 0 here, and we have 1, 2, 3, 4, 5 places we are shifting. 6.95 into 10 to the power. How many places did we shift? 5 places towards left. So 5. Got it? Okay, the next one is this one, 5,36,000 we have. So we can just, consider a 0 after this, like this. And when we shift this 1, 2, 3, 4, 5. So 5.036 into 10 to the power. How many places? 1, 2, 3, 4, 5. Plus 5 because it is left side. Now here we have to move towards right after 1. So how many places? 1, 2, 3. So 1.6 into 10 to the power minus 3. Clear? The next one again move after 3. 1, 2, 3, 4, 5, 6. So 3.0 into 10 to the power minus 6. 1, 2, 3, 4, 5, 6 places we are moving. The last one is 8,848. 8,848 meter. Like, so what we can do is just see if after this there is a decimal, we can write it as 8.848 into how many decimal places? 1, 2, 3. So 10 to the power 3. Like this we can write. Okay. So now we are going to move to questions that are going to practice. It is just told here that how are you going to practice with, real life examples are shown here so that you know the use of it. Now, if you see here how to compare very large and very small numbers. So we have diameter of sun and diameter of earth. Diameter of sun is 1.4 into 10 to the power 9 meter, and here we have 1.2756 into 10 to the power 7, right? So see, the powers are different, we cannot compare. So what we need to do is we will make the powers same. Okay, if I have to make the power same, what I need to do? Either I make this as 10 to the power 7 or I make this as 10 to the power 9. Right, that's the only case. So just see, if I have to make it 9 or if I have to make this 7. So for reducing the power, we need negative powers, and for negative powers, where we have to move? To the right side, otherwise to the left side. Okay, so we have 1.4 into 10 to the power 9, and here 1.2756 into 10 to the power 7. If I have to make this 10 to the power 9, I have to multiply it with 10 to the power 2, and I have to divide also with 10 to the power 2. So I get 1.2756 divided by 100 into this will form 10 to the power 9. Now the decimal is here. Okay, so 1, 2, 3, 4. 4 places is there. So it is just 10 to the power 4. So total is 10 to the power 6. So 1, 2, 3, 4, 5 and 6. So we will write it as, just see. That means the decimal will be 2 more places. So we can write it as 0, 1, 2, 7, 5, 6. Where will be the decimal? Shift it by 2 places. So after 1 and after 0, it will be like this, 0.012756 into 10 to the power 9. So is now when powers are same, 10 to the power 9 both case, if you compare these parts, which one is greater? This one. So this is greater. Okay, which is greater? The diameter of the sun is greater. Is that clear what we have done? See, I had this. To make 10 to the power 9, I have to multiply and divide with 10 to the power 2. So this formed 10 to the power 9. 100 is there, I have to shift the decimal to 2 more places towards left, right? So that I have done. Clear? Now, here mass of earth is given and mass of moon is given. So we have to tell the total mass. Now can we add when powers are different? We cannot add when powers are different. We have to make the powers same. So just see. 5.97 into 10 to the power 24 can be written as 10 to the power 22 into 2 plus 7.35 into 10 to the power 22, and whole is in kilogram. We are finding the total mass. So you can just write total mass. We will be left with 5.97 into 10 to the power 2 plus 7.35 and 10 to the power 22. We have taken common from both. Okay, now we have 10 to the power 2, that means we are multiplying it with 100. So you see 597, if you remove the decimal it will be 100 in the denominator and 100 here, plus 7.35 into 10 to the power 22. 100 and 100 got cancelled, we have 597 plus 7.35 into 10 to the power 22 kilograms. So can we add them? Yes, we definitely can add them. 597 and 7.35. 7 and 7 is 14, 9 and 1 10, 5 and 1 6. So we have 604.35 kilogram. Okay, so this is how we compare or how we add them. Okay, so whenever addition is asked, you just have to make the power same. So we did it 10 to the power 22, that came up. So then we are left with 10 to the power 2. So whenever we have powers in positive, that means the decimal will be shifted. Right, now we have 10 to the power 2 as a positive number. So positive number comes when we shift the decimal towards left. So that means if this is here, to cancel this we have to shift it here, or you can just remove the decimal like this and solve it. Okay, moving ahead, here we have to express the number in standard form. So after how many places? After 3 we have to write the decimal. So we'll write 3.5 into 10 to the power. First thing, which side are we moving? Right side. So positive or negative sign? Negative sign will come. How many places are we shifting? 1, 2, 3, 4, 5. Minus 5 will come up. In the second one, we have 4050000. So suppose the decimal is after this. How many places will we shift towards left? So if we are shifting towards left, 10 to the power positive number will come. So 1, 2, 3, 4, 5, 6. So 4.05 into 10 to the power 6 places we have shifted, so plus 6 will come. Right? How many places? 1, 2, 3, 4, 5, 6. Right? Moving ahead. Here we have to express them in usual form. That means only normal numbers we have to write without this decimal. So we have 352. If I remove this decimal 3.52, it will become 352 and 10 to the power 2 into 10 to the power 5. So 352 into, when we solve this same basis and division, powers will get subtracted. 5 minus 2 is 3. So 352000 is the answer for that. Second part. We have 7.54 into 10 to the power minus 4. So we write 754 upon 10 to the power 2 because 100 will come up into 10 to the power minus 4. We are left with 754 into 10 to the power minus 4 minus 2 will become minus 6. Now 754 upon 10 to the power 6 is there. That means after 6 places there will be a decimal. 1, 2, 3, 4, 5, 6. So it will be 0.000754, like this the answer would be there. The next part is 3 into 10 to the power minus 5, the third part. So we will write 3 upon 10 to the power 5. That means after 5 places we have to put the decimal. 1, 2, 3, 4, 5, like this. This would be the answer. So easy to write.